Okay, so welcome to Learning Target 5, the discriminant. Learning Target 5 says the discriminant is used to predict the number of solutions to a quadratic equation. So we open this lesson with the question, how many roots can a quadratic function have? So I actually want to take the opportunity to define what root is. A root is just an answer for x when you're solving a quadratic equation. A root for a linear equation is the answer for x when you're solving a linear. It's the same thing with a quadratic. It can be the x-intercepts or the zeros, but it doesn't have to be. For the sake of this warm-up question, we are going to talk about where it does equal 0, just for simplicity. So quadratic could have two roots, and so this is where this equation equals the y value equals 0. You could also talk about where the y value equals 3, it has two roots as well. Equation could have one root, so where the y value equals 0 here, it only hits it once, or it could have no roots, and that's where it doesn't hit 0 at all. Okay. How can we find the number of roots without solving? We actually look at the quadratic formula, and we realize that we can't take the square root of a negative. So the only part of the quadratic formula that actually matters to tell you how many roots there are is that b squared minus 4ac. That's what we refer to as the discriminant. If the discriminant is greater than 0, there are two roots, and that's because the plus minus is kicking in. No matter what that number is, decimal, radical, whatever it is, whole number, there's going to be a plus 1 and a minus 1, and so you're going to have two roots. If it equals 0, there is one root. I had to change the grammar. Because we're doing plus minus of 0, it doesn't really do anything, so you get the same thing. So plus minus 0 is the same. B squared minus 4ac is less than 0, then there are no roots, and that's again because you can't take the square root of a negative. Okay, so pretty easy concept. It's the discriminant. It's valuable because it's a good just check quickly to see if you can actually continue. The discriminant is something you need anyway, so you might as well just calculate it on the side on its own, and then if you have to continue to get the roots, then you can plug it in. So an application here is a profit function for the first year of a business. X is the number of items produced. Will it be possible to break even? And so you've got the amount of money that they're profiting. So break even happens when p of x equals 0, so when the profit equals 0. So if we look at that equation, you'd be inclined to actually solve that with the quadratic formula. And so we'll try to solve it with the quadratic formula, but we're just going to check to see if you can actually break even, if it's even possible. So you take the discriminant, sub in what you have, 3 squared minus 4 times negative 0.3 times negative 15. That gives you 9 minus 18. The answer is negative 9, and that it doesn't really matter what the answer is, but as soon as you realize you're getting a negative, which is less than 0, that's telling you that you're not going to be able to do it. Because you have a negative under the square root, the company cannot break even. The company is not going to be able to have answers to this question. And just you don't have to draw it, but just visually what happens is you've got something that's trying to hit a profit, but it's actually never going to profit. And if you produce more items, it'll just make it worse. The company won't profit in the first year. Okay. For value k, does the quadratic function 2x squared minus kx plus 8 have one root? These are really just interesting questions to solve, and they're just really playing with the learning target, playing with the discriminant. So regardless of what it asks you, if it asks you for one root, two roots, or no roots, you actually want to solve for the case where it's one root first. What that allows you to do is, because that allows you to actually solve an equation. It actually allows you to solve the equation equal to 0. If you're trying to find out where it's two roots, it's just helpful to find out where it's one root first, because the two roots will actually be solved after that. You don't want to have to solve a inequality. It's something we do in advanced functions next year. So we sub in what we know. We don't know what b is, so we write in k. Some people like the common mistake here is, how do you know what b is? Isn't it -1? It's not -1. It's the coefficient on x, and that's -k. Minus 4ac gives us k squared minus 64 equals 0. Ironically, this actually gives us a quadratic. It's not the same quadratic as this quadratic above, but it is a quadratic. And so this is the best example that we have of solving a quadratic where it's not really related to the function that we have in question. It's related, it comes from that function, but we've actually created an equation of a quadratic. So we're going to solve the quadratic equation. It's a really good question because so you're going to see it on the quiz and the test. It's a really good question because it requires you to solve a quadratic for solving a quadratic, for finding the answer. We can factor that quadratic to difference of squares. You could also put the 64 on the other side. It is in vertex form as well. So you could put the 64 to the other side and then take the plus minus square root. Either way, you get two answers, k equals 8 and k equals -8. If we graph the discriminant, not the function, the discriminant, it would have zeros of -8 and +8. It would open up, and it would have a step pattern of over 1, up 1. But really, and it would have a vertex of 0, -64. The y-intercept would be at -64. If we graph that, this is what we get. These two values here are where the discriminant equals 0. So you can see that the discriminant, the height of it, equals 0. The values outside, so when k is bigger than 8, or k is less than -8, we also call this the absolute value of k is bigger than 8. That's in these cases here. So you've got this part and this part onto infinity. You get two roots because the discriminant is positive. We've got a positive value here. When k is between -8 and 8, remember from domain and range, that's how we say if something's between. So if k is between -8 and 8, so in this case, in the middle here, so all the way, we get no roots because the discriminant is negative. This is a really valuable thing to do, to actually just quickly graph the discriminant. And all you need, you don't even need to graph the y-intercept. All you need to understand is it's a parabola with these zeros and it's opening up. That's all you need to understand. So if you can graph that discriminant, you can find a little bit more about it. And that really does help. So whatever you get for a discriminant, if you get a quadratic or even a line, it does help to graph it just to see where is it positive and where is it negative. So a line that would look like this, opening with a positive slope, would have one root in the middle when k is in the middle, no roots when k is below, and two roots when k is above. Okay, so there's your practice for today.